based on the nature of organic compounds and the impurities present in them. Organic compounds can be purified using 5 different methods. These are sublimation, crystallization, distillation, differential extraction, and chromatography. In this module, we will look at the first 3 methods. Sublimation technique is used to purify sublimate solid organic compounds. You have learned that sublimation is a process which involves the conversion of a solid directly into vapor without any intermediate liquid state. This process is used for separating sublimable compounds from non-sublimable impurities. In this process, the impure substance is heated in a dish covered with a perforated filter paper over which an inverted funnel is placed. The stem of the funnel is plugged with a little cotton. Vapors of the solid, which sublime, pass through the holes in the filter paper and condense on the cooler walls of the funnel. The non-volatile impurities are left behind in the dish. Iodine, camphor, naphthalene and benzoic acid are purified by this method. Now let's look at the next method of purification, called crystallization. It is one of the most commonly used techniques for the purification of solid organic compounds. This technique is based on the difference in the solubilities of the compound and the impurities in a suitable solvent. In this process, first, the impure compound is dissolved in a solvent in which the compound to be purified is moderately soluble at room temperature and highly soluble at higher temperature. The solution is heated to get a nearly saturated solution. This saturated solution is then cooled to obtain the compound in its pure crystal form. The crystals are separated out from the filtrate by the filtration technique. The crystals are washed once or twice with small quantities of the pure solvent and dried by pressing between the folds of filter paper and then placed in an air oven. Sometimes impurities impart color to the solution. To remove such impurities, the filtrate is passed through activated charcoal. The charcoal absorbs the impurities. The solution is then filtered and recrystallized as described above. Now let's look at the distillation process. This method is used for separating volatile liquids from non-volatile impurities, and also to separate the liquids which differ in their boiling points. Simple distillation is used when the liquids in the mixture differ appreciably in their boiling points. For example, a mixture of chloroform and aniline, which differ in their boiling point by 123 degrees Celsius, are separated by this technique. In this method, the liquid mixture is taken in a round bottom flask which is fitted to a Liebherr condenser and heated. On heating, the vapors of the liquid with the lower boiling point are formed first, and at a constant temperature, whole of the liquid changes into vapors. The vapors are condensed by using a condenser, and the liquid is collected in a receiver placed at the open end of the condenser. The vapors of the liquid with higher boiling point that are formed later are also condensed, and the liquid is collected separately. Simple distillation cannot be used in the separation of liquids which do not differ much in their boiling points. Another technique called fractional distillation is used to separate liquids which have small difference in their boiling points. In this technique, a fractionating column is fitted over the mouth of the round bottom flask. The purpose of the fractionating column is to increase the area of the cooling surface and to provide hurdles to the ascending vapors. The vapors of a liquid mixture are passed through this column before condensation. As the liquid boils, the more volatile component rises to the top. Some of the condensing liquid obtains heat from the ascending vapors and gets vaporized again, becoming richer in low boiling component. These vapors of low boiling component rise to the top of the column, becoming purer as they reach the top. The pure vapor is passed through the condenser and the liquid is collected in a receiver. The remaining liquid in the distillation flask becomes rich in high boiling component after a series of successive distillations. Each successive condensation and vaporization unit in the fractionating column is called a theoretical plate. The technique of fractional distillation is used in the separation of different fractions of crude oil in the petroleum industry. In the case of liquids with very high boiling points and liquids that decompose below their boiling points or at their boiling points, another method called distillation under reduced pressure is used for purification. In this method, the pressure on the liquids is reduced with the help of a water pump or a vacuum pump. As we know, a liquid starts to boil when its vapor pressure becomes equal to the external pressure. Thus, reducing the pressure on the liquid surface reduces the boiling point of the liquid. In soap industries, glycerol is separated from spent lye using this method. Another distillation process, steam distillation, is used to separate substances that are immiscible with water and steam volatile. That is, get evaporated when steam is passed through them. In this process, the liquid to be distilled is kept in a heated flask and steam from the steam generator is passed through it. The mixture of the steam and the compound is condensed and collected. The compound is separated from water using a separating funnel. In steam distillation, the liquid boils when the sum of the vapor pressures due to the organic liquid and due to water becomes equal to the atmospheric pressure. Since the vapor pressure of organic liquid is lower than the atmospheric pressure, the organic liquid vaporizes at low temperature than its boiling point. Hence, if one of the substances in the mixture is water and the other is a water-insoluble but steam-volatile substance, then the mixture will boil close to but below 373 Kelvin. Aniline is separated by this technique from an aniline water mixture.